Hey students, welcome back to my YouTube channel Kame Studies. Here, I Vrushika Rana will explain the concepts of chemistry class 12th in amazing ways. So, stay tuned with the channel and please like, share and subscribe for others also. So today, we are going to see the general characteristics of solid state and types of solid state, chapter 1, the solid state. Yeah, this video is already on my channel, but yes, there are some quality issues regarding it, so I am reloading it. Okay, so yes, in this chapter, in this class, we are going to study the solid state in a deeper manner. In our earlier classes we have also seen about solid state, right? But in this class 12 we are going to study regarding solid state in a deep manner. So first, the topic is general characteristics of solid state. These are those characteristics that we are learning in our earlier classes. Okay, so if I am moving ahead, the general characteristics of solid state. So general characteristic of solid state, there are four different characteristics, right? The first is having definite mass, volume and shape, right? So yes, if it's a solid, then it is obvious that neither your mass nor your volume and nor your shape is going to be changed. If I'm taking the example of this pencil, I can't even change the shape of it. So yes, if I'm not able to change the shape, my mass and volume is already going to be same. Hope you got this. Okay, the next is intermolecular. So if we are moving to intermolecular, I am having two different things for intermolecular, that is my intermolecular distances as well as my intermolecular forces, right? So what are intermolecular distances? So intermolecular distances, right, are those which are very short, right? Intermolecular, which means it is happening between two molecular, right? It is happening between two molecules, right? The distance between the two molecules is going to be just short. And yes, if I'm talking for intermolecular forces, so what are intermolecular forces? So intermolecular forces, I have written here for your information that intermolecular forces are those forces which tend to keep molecules closer, right? Which says that it is having that much of property that it can bind your molecules close to each other, and hence my intermolecular forces are going to be the strong. Okay, the third is my constituent particle. If I'm moving to constituent particle, my constituent particle, which may be either atoms, molecules or ions, right? My constituent particles may be either atoms, molecules or ions. And yes, my constituent particles should have my fixed position, right? My particles is going to have fixed positions. Next is it is incompressible and rigid, right? You can't compress it, you can't stretch it, and hence it's a rigid object. So now we are going to move to second topic, that is my types of solids and its difference. I hope you understand the first topic, that are my general characteristics. Okay, yeah, the second topic, as we have discussed, that it is types of solid, right? There are two different types of solid and we are going to see its difference also. What is the major difference between both this? Okay, so stay tuned with Kame Studies. Solids, so it is divided into two different categories, or you can say two different parts, that is amorphous solids and crystalline solids. So what are amorphous and what are crystalline? So amorphous is a regular pattern of arrangement of particles over a short range order, right? Over a short range order. So my pattern is repeated, my regular pattern, certain pattern is repeated for short range, right? Short range means only for a short time. Okay, so regular pattern of what? So regular pattern of arrangement of particles, right? Over only for a short range order, that is only for a short time. And yes, if I'm moving to crystalline, so for crystalline, regular pattern of arrangement of particles over a long range order, right? It is repeated over a very long time. Crystalline, that is regular pattern of arrangement of particles over a long range order for a very long time. My regular, or you can say certain pattern, is repeated. So yes, if I'm moving to the examples, so the example for amorphous is going to be the glass, rubber, plastics, etc. Right? You can see that you can stretch it easily, right? You can stretch it, right? So yes, my amorphous is having only short range of order. And if I'm moving to crystalline, my crystalline consists NaCl, that is my sodium salt, and next is SiO2 with quartz, right? You are going to remember that what is quartz. Quartz is, the formula for quartz is SiO2, right? Now if you are moving, the major difference between them is for my isotropic and anisotropic, right? The major difference between the amorphous and the crystalline is going to be the isotropic and anisotropic. So let us have a look for isotropic and anisotropic and what is the difference. So yes, if I'm moving to isotropic, isotropic says that it is having fixed properties in all direction, right? My properties are going to be fixed. So fixed properties, so I have written that what are going to be the properties which is going to be fixed in all different directions. So that is going to be mechanical strength, mu. This u like symbol, if you see, this is called as mu, right? And the it is symbolized for my refractive index. Next is electrical conductivity and etc. So yes, let us look to the anisotropic. So what is anisotropic? Anisotropic is my different properties is repeated in different directions. So I have written in simple language that different properties in different directions. Okay, and which properties in anisotropic? So for anisotropic, properties like electrical resistance, and this is mu, this is my refractive index, etc. So I hope you understood this. So for a clear and a better understand for what is amorphous, crystalline and isotropic and anisotropic, let us quickly move to the example. I hope you can clearly see this. I hope you can clearly see this. The thing that I am going to show you is that is amorphous. Amorphous, my regular pattern is repeated, right, for a short range, right? For a short range. Is it for a short range? Correct. Is it for a short range? Yes. If you can see that my this is my A and this is my B, again this is A, and again if you see this is B, again A and again B. So if you see, I am having a regular pattern. So you can see A, this is my A, this is pattern B, pattern A, pattern B, pattern A, and hence it is going to be continue. So yes, my regular pattern is repeated over for a long range. You can see that it is for a long range. So hence it is called as crystalline. Hence it is called as crystalline. And yes, if I'm moving here, so you can see, if you are moving to only this three, right, you can see that, yeah, this is, if you are comparing this to this, so you can see that A, this is my A, and if you see that this is my B, but only for this three, right, my pattern is repeated. So as we have seen that no pattern here, the pattern is there, but it is not a regular pattern. It is a regular pattern but only for a short range. So hence it is called as amorphous, right? You are also given a quickest figure in your textbook also. So yes, as if we have talked for anisotropic and isotropic, right, we are going to see it. Yeah, so let us have a quick example. This is the example of textbook itself, so it makes easier for you to understand. So yes, first if I am moving to A, from A to B, if I am moving from A to B, I am having fixed properties. If you see from right hand side, you are having red balls from A to B, red hollow circles from A to B, and if you are moving to A to B from your left hand side, you can see that you are having blue circles, you are having blue balls, right? So if you see, either it is in this direction, either it is in this direction, right? My pattern is going to be same, sorry, in both different directions, right? My properties are fixed, hence it is called as isotropic, and hence if you are moving from C to D, right, from C to D, either from your left hand side, right, I must say that either from your lower side or either from your upper side. If you see red, blue, again red, blue, red, blue, red, right? So yes, in the same way from the upper side, if you see, you are having different properties in all different direction, and hence it is called as anisotropic, right? So my amorphous solids are going to be isotropics and my crystalline solids are going to be anisotropic. So let us have a quick look on the difference between amorphous and crystalline solids. If you're moving to this is the difference between amorphous and crystalline solids, right? It is again the most important question for your 3 marks. You can see, I have already written here that it is most important for 3 marks for board exams, as well as it is already asked in MCQs, right? It may be asked in MCQs. Let us have a quick look towards the difference. So yes, amorphous solid, right, it is having irregular shape, or you can even say that my pattern is not repeated for a long range order, that is, it is my short range order, right? So first 2 points are completed here. So for crystalline solids, it is having definite characteristics and geometrical shape, right? If you can see, it is going to follow a regular pattern, and hence it is having a geometrical shape and long range order because it is repeated for a longer time. And next, if I'm proceeding ahead, gradually soften over a range of temperature. So yes, if I'm moving to this, so it is having gradually soften over a range of temperature, right? So I am going to have a certain range, right? And for if you're moving to here, it is having a melt at a sharp and a characteristic temperature. You can even write that it is having the exact point. So yes, I am going to show you, wait a second. So yes, you can see this. This is for my amorphous, that it consists of a kind of a range that is 283 to 290 Kelvin, right? This I have only taken the example, right? I have only taken the example for range. This is not the exact thing, but yes, if you are moving to this is for my crystalline, that it shows my exact melting point, and if you are moving to this, it shows me only range. Hope you cleared this. Next, if proceeding ahead, I am given then when cut with a sharp edge tool, it's split into two surfaces. It's split into two irregular surfaces, right? If you are taking any solid and if you are cutting it, right, so it is going to show you two irregular surfaces. But yes, if you are moving to crystalline solid, what it gives you, when cut with a sharp edge tool, it's split into two surfaces and the generated surfaces are plain and smooth, right? Here it is two irregular surfaces, right? And here it is absolutely correct, two regular surfaces, and those surfaces should be plain and smooth. Next is they do not have definite enthalpy of a fusion, right? They do not have any finite energy. And if you are seeing this, they are having definite characteristic enthalpy of a fusion, as we have seen that amorphous solid are isotropic in nature and crystalline solids are anisotropic in nature. Next, proceeding ahead, these means if you are moving to this, these are called as my amorphous solids. So my amorphous solids are also called as pseudo or supercooled solids. As you can see here, my amorphous solids are also called as pseudo or supercooled solids, and my crystalline solids are called as true solids. Crystalline solids are called as true solids. Next is quartz, glass, plastic, rubber, etc., which are the example for my amorphous solids, right? And for crystalline solid, the examples are NaCl, quartz, etc., are going to be the examples. Hope you understand this. So yes, if you have understood it, just write in the comment section crystal clear, so that I can know that yes, you have cleared it like that of water. Okay, so stay tuned with the channel and please subscribe it if you are new to the channel. And don't forget to press the notification bell in order to get the notified first. So see you soon in the next video. Till then, have a great day, dear.